Hello and welcome to everyone in today's class, and today we are going to take the new topic in the physics, and the topic is magnification. And the topic I have told you is magnification. The word magnification itself tells you the word that it consists of a word. It is magnify, and the magnify means how much larger. That means if you are going to find out the magnification of a mirror, that means to say the object, that there will be a relationship between the image size and the object size. So exactly what is magnification? Magnifying, you must have heard about the magnifying glasses. What does it work? How does it works? Or what is the function of magnifying glass? It enlarges the image of the object. So here also, when we are going to discuss about magnification, then we'll deal with the thing that how much larger or smaller, that means how many times the image is smaller or larger from its object. So what is magnification? If we want to give the definition, it is expressed as the ratio of the height of image to the height of object. It is usually represented by the letter small m. So we have written that it is expressed as the ratio of the height of image to the height of object. That means if you have taken, that means magnification, if it is expressed by m, then m can be written as ratio of. Ratio means this sign. Ratio of the height of image. Suppose that h dash is the height of the image and h is the height of object. If h dash is the height of image, what h dash stands for? It stands for height of image. And what does h stands for? H stands for height of object. So if h dash is the height of image and h is the height of object, then magnification m is equals to h dash upon h. Let it to be equation number 1. Now, as we have seen in the ray diagrams, that the height of the object or the size of the object is dependent upon the thing that how much distance you have taken for the object from the pole. If you have taken the lesser distance between the object and the pole, the larger will be the image. And if you have taken much distance in between the object and the pole, then you will be getting comparatively smaller image of the object. So this image size is also correlated with image distance and object distance. As you have written here, magnification is correlated with h dash and h. So the magnification can also be related as it, or it is expressed as, or it can also be expressed, or it is also expressed as the ratio of negative of the image distance v to the object distance u. What does v stands for? Image distance. That means distance of image from its pole. And what does u stands for? U stands for object distance from the pole. It means to say that if you have kept the object at a distance u from the pole and you are getting the image at v units from the pole, then magnification m is equals to minus v upon u. Let it to be equation number 2. So what you are getting from equation 1 and 2, from equation 1 and 2, we have, when you are going to compare these two equations, you are having, because the left hand side in the equation 1, that is also equal to the left hand side of the equation 2, so we can compare the right hand side of both the equations. So this will imply that h dash upon h is equals to minus v upon u. This is a very important formula which you are going to use in the further section of the chapter. That means the important section, that is numerical section of the chapter. Now the one query that is in your mind, that what is the speciality of the formula, or what does this negative sign indicates? If in the question you are getting that if m is negative, so just think from this formula. Always remember, u is always negative, because object is always placed on the left hand side of the pole. So the distances which are on the left hand side of the origin, they are taken as negative. So u is always negative. When u is always negative, just think over here, m is equals to minus u v upon u, and u is always negative, so that means the value which you are going to keep over here, that will be negative. So this minus sign will get cancelled out. But if in the question, so m will be positive, but actually in the question it is given that if m is equals to negative, that is only possible when v is negative. So the condition is, if m is equals to negative and v is negative only and only when the image is formed on the left hand side of the object, left hand side of the pole, that means it is real image. You are getting the image in front of the mirror. So if m is equals to negative, then image is real. And second note, if you have taken m to be positive, then what happens? Again, take this example, m is equals to what? It is minus v upon u. U is always negative. So if you are going to substitute minus 3, minus 4, minus 5, this minus sign will get cancelled out. You are getting m is equals to plus v, and plus v means on the right hand side, that means virtual image is formed. So if m is equals to positive, then image is virtual. So if in the question it is given that the image so formed is real, the image is formed 2 times larger than the object, a real image, a 2 times larger real image is formed, you will simply write down m is equals to minus 2. And if in the question it is given that a image is virtual, then you will keep the magnification to be negative. So by just looking at the sign of the magnification, you can reach to the conclusion that either the image is real or the virtual. If m is equals to negative, then image is real. If m is equals to positive, then image is virtual. This is all about the topic magnification. These are the two simple key concepts, that magnification is equals to height of image to the height of object, and m is equals to minus v upon u. When you will compare both these two equations, you will get h dash upon h is equals to minus v upon u. And then further we have discussed about the negative and positive sign of the magnification. This is all about magnification today, and this was the last topic of the chapter, chapter reflection of light. Now the next video will consist of the numericals, how you are going to solve the numericals. Okay, so wait for that. Thank you.